So hi everyone, welcome back to my channel. So today we're going to do a simple binary tree problem which is in-order traversal. So in a binary tree, there are three nodes, and in each tree node it stores the value of the node. So it's most likely to be an integer, but it could be something else. And it has two pointers. The left pointer points to the left tree, the left subtree rooted at this node, and the right points to the right subtree rooted at this node. So in-order traversal here basically means at any node, visit left subtree, visit it the node itself, and then we'll visit the right subtree. So basically, the reason why this is called in-order traversal is because in a binary search tree, the left subtree, the values under the left subtree must be, the values in left um, subtree must be less than or equal to the node, and which should be less than or equal to the right subtree. So if we visit the tree nodes in this order, then it will be an in-order traversal. So how can we do it then? So basically, eventually we will return a list of integers. So basically, we need some kind of way to traverse the whole tree and grab the values in the correct order. So what I can think of is you can use a DFS. So the easiest way to do this is to use a DFS approach. And so for DFS approach, it is defined on a tree node, and um, if the node is empty, if the node pointer is empty, then we do nothing. And after we handle this corner case, we can start with the logic for in-order traversal. So basically, we need to visit left subtree. We need to visit the right subtree, and in the middle, we need to visit the root dot value itself. And so this function works on any tree node of the tree. So if you call this function in any tree node, it will work on that subtree. But what we want is we want to have the in-order traversal of the whole tree. So we obviously want to call this on the actual root of the tree. So another thing we need to care about is whenever we want to visit the left subtree, we want to make sure the left subtree exists. So we want to do something like if root dot left is not none. So this simplifies to just if root dot left. So if this is the case, we want to do something, and the same thing applies to the right subtree. If this is if the right subtree exists, we want to do something. So what is it that we want to do? What we want to do is that we want to collect the node values in a list. So initially the list should be empty, and whenever we visit a node, a tree node, we will just append that value into the list. So here we're actually visiting the value of the root, the value of this tree node. So we're just gonna append this into the list. And for the left subtree and the right subtree, we're basically going to recursively call the function. And when the left subtree exists, we need to recursively call it on the left subtree. And the same thing applies to the right subtree. And in the end, we'll need to call this recursively on the root node of the original tree. And in the end, the res array should should have all of the values of the tree nodes which are visited in the order of left subtree, tree node, and right subtree. So it should be an in-order traversal order, in-order traversal. So in the end, we can just return res. So this should work, and that's pretty much it for the video, and thank you for watching. See you next time.